Hello. So, in the previous segment, you saw how to create the various different types of word vectors. So, that is how to create the occurrence matrix, co occurrence matrices. What are the advantages of creating the word vectors? Why are we creating the word vectors, etc. So, throughout this segment, you might have noticed that the matrices which we generally create, that is, it might be occurrence matrix or the co occurrence matrix, we have a major drawback or the major demerit, that is the size of the matrices. Suppose if we create a matrix based on the occurrence matrix technology, so there what happens if there are 1000 documents or 10,000 documents, say there will be 10,000 columns or 10,000 context columns, right? So in most of the things, what happens, suppose if we have taken say 10 vocabulary words and 10,000 documents, so it is not necessary that all those 10 words would be present in all the 10,000 records. Then in most of the columns, it would be generally zero value, which means we have created such a large matrix and it is such a vast dimension. And if we try to feed these kind of information into our deep neural networks, it takes very more time to understand the patterns for the neural network, right? Even if you create the co-occurrence matrix through co-occurrence matrix, even then, suppose if I have a vocabulary of say 10,000 words, then it would be a square matrix of 10,000 cross 10,000. Definitely it would be a large matrix, right? Apart from all these disadvantages or all these demerits, there is another major demerit, that is the polysemy of the word. I have already mentioned what is polysemy, right? So I have taken an example of Java, right? So Java have three different meanings, like one it is a coffee, other it is an island, and third it is a programming language. So these kind of polysemic word and other grammatical correlations such as synonyms, antonyms, meronyms. So all these kind of words will be a major challenge when we try to create a co-occurrence matrix or a occurrence matrix. So the size of the input matrices would be very large. It would be memotic shape, right? So to avoid this or to overcome this, we have to reduce the dimensions of the input, right? We have to reduce the size of the input. So suppose, have you ever thought, why don't we just apply some factorization of that particular matrix? Or suppose if we have a SVD technique, why don't we reduce the size of the matrix to the lower dimension, right? So that is what we exactly do in our next topic, that is word embeddings. So the word embeddings aim to reduce the dimensions of the large size input matrix to the lower dimension input matrix. Suppose say I have each row which may size around 100 rather than 10,000. It is better to reduce it to hundreds, right? Even the word embeddings would not be reducing the entire matrix to a smaller matrix, like to the least size matrix. Instead, what it will do, suppose if we have 1,000 rows, it will be coming up to 100 rows. So it is better, right? The size of 1,000 will be very much better compared, that is the size of 100 is very much better when compared to the 1,000 size rows. So that's what we will try to do in the word embeddings. So as I mentioned, there are other semantic association which may interrupt our size of the, or which may concern over the size of the input matrix, right? So I have taken one such example. Say I saw a man sleeping on the footpath. This is one such context, and I have taken two words, man and footpath. I'll take another sentence. There is no room for pedestrians to walk on the sidewalks. Here you could see the man and pedestrians mean the same. It is the synonym. And this footpath and sidewalk also mean the same. Even these are synonyms. Since these are used in a different context, so we couldn't able to track these repetitions of the words. We could have replaced this word man with the pedestrians if we have got the occurrence of these contexts side by side. So this dimension may occur at one part of the document and where the other sentence may be occurring at the other part of the document. So we couldn't able to track these similarities when we try to create using occurrence or co-occurrence matrices, right? So these kind of semantic associations will be tracked if we try to reduce the dimensions of the input matrix. That is, suppose if we convert suppose if we convert our raw matrices, that is co-occurrence or the occurrence matrices, which are millions of dimensions, through applying certain techniques called like SVD, SIBO or skipgram method, and if we try to reduce these dimensions of the input vectors or the co-occurrence matrices into a embeddings or the lower dimension word embeddings, or with hundreds of dimensions. So here we had millions of dimensions, but if we try to reduce it to hundreds of dimensions, it is very easy for our analysis, or it is very for our easy for our neural network to understand the patterns, and we could able to track these kind of similarities and these kind of synonyms which may occurring in the different sentences. So in the further sessions, I am going to explain you what are we doing, what are we trying to do in order to produce our word embeddings. In other ways, I am going to explain you what are the different ways we can create the word hello. So in previous session, I explained you so why we are creating the word embeddings and what are we doing in the word embeddings. So here in the word embeddings, we are basically converting the high dimensional matrices, that is co-occurrence or the occurrence matrices, into a lower dimension matrices using certain techniques such as SVD, PCA, SIBO or skipgrams. So in this session, I am going to explain you two popular techniques which are incorporated at the stages of development of word embeddings. So at the initial stages, when in 1990s, when the word embeddings development started, they started with the two major approaches in order to create the word embeddings. So the word embeddings can be generated with the following two broad approaches. That is, one, frequency based approach, and the second one is prediction based approach. So in the very first approach, as the term mentioned, frequency based approach. Frequency is nothing but a count based approach. So and where do we see the count based approach, or in which matrix we can apply this? Definitely it would be the occurrence context, or the occurrence matrix which we created at the first time, where the columns will be context or the document and the rows will be words or the terms. So we will be applying this frequency based approach to the term document matrix or the occurrence matrix. So we will apply this frequency based approach in order to reduce the term document matrix, which can also be termed as a TF-IDF or incidence matrix, etc., using a dimensionality reduction technique such as SVD. SVD is also termed as, or elaboratively known as, single value decomposition. So we can have also applied other techniques which are very popular. Instead of SVD, we can also apply eigenvalue decomposition or non-negative value factorization, etc. So the major intention is to reduce the size of the term document matrix. So this is one such approach. So the very popular model or very popular word embedding which could be able to generate out of frequency based approach is LSA. LSA is nothing but latent semantic analysis. So I'm going to explain in detail about LSA and it is built on top of frequency based approach. Then another popular method or another popular approach which we follow in order to generate the word embeddings is the prediction based approach. And as I mentioned, this frequency based approach is applied on occurrence matrices, whereas this prediction based approach we are going to apply this on co-occurrence matrix or term document matrix or term matrix. So in this approach, the input is a single word. So we are going to take an input as a single word or the combination of words. So combination of word in the sense a pair of words. The pair of words which we created in the co-occurrence matrix. Just say fly and sitting. So that would be the input for the this method. So and the output we are going to expect a combination of context words. Combination or might be a single word. So what we are going to do, we are going to train a neural network or a shallow neural network which can learn the embeddings such that it can predict the output words based on the input words. So suppose if I pass two words or a single word, say cat, then the output of the neural network could be based on my trainings. Suppose if I want the similarity of the words cat, then the shallow neural network or the word embedding which we going to create on the prediction based approach will be giving the similar words for the cat. The similar words for the cat would be kitty, pussy. All these kind of words will be generated based on the shallow neural network. And the approach we are going to use to in order to predict the word or the prediction based approach is the one key factor which we are going to apply in the word embeddings. So this is in brief or overview about the word embeddings. So in the later sessions, I'm going to explain you each one of such example for each approaches. So I'm going to explain you how to build or how LSA is built or how frequency based approach is used in order to generate a word embeddings. And also I'm going to explain another approach, that is prediction based approach, to generate the very popular, very commonly used word embeddings such as word to vec and glow models with the hands-on example.